Welcome to Study Loop.
For this question, we are given a preliminary regression analysis output that a coach performed on a sample of 293 players from the NHL, and he was seeking a relationship between shots taken and goals scored. And for this question, we are asked if the necessary assumptions for linear inference are met for this problem. And so there are four main assumptions. So the first one is the linearity assumption. So the data actually has to be linearly related in order for it to be valid to do a linear regression. And one thing we can do is look at the first plot that's provided in the question, which is a scatter plot of the shots taken versus the goals scored. And we want to see if that forms a fairly straight line. So if you look at this scatter plot, it definitely looks like a linear relationship. Like you can imagine a line passing through there. The data is formed in a linear fashion from the bottom left towards the top right. So that speaks to the linear assumption. So we can say that that has been satisfied. And the independence assumption, so we'd want to know that it's a random sample of players from the NHL. We're not actually told that in the question, but that would be good to know. The other thing we can do is look at the residuals plot, which is the second plot provided in the question. And here we want to see if the scatter is a random scatter of data. We don't want to see any clumping or patterns or trends in the data. So looking at the scatter plot of the residuals, it does look very good. It looks quite random. And I would say that the independence assumption is therefore met. And now the third one is the equal variance assumption. So again, we use the residual scatter plot for this. And what we want to see is we want to see steady variance as we move from left to right in the scatter plot. So the variance is how far the data scatter vertically for a given shots. So for a given point on the x-axis, how far do the data scatter? We want that to be about the same as we move from left to right. So we don't want to see a fanning out effect or a fanning in effect as you move from left to right. You just want to see kind of like a horizontal column of random data. And I would say that the scatter plot for residuals in this question is very good in that regard. I would say that the equal variance assumption is met. And fourth, we want the errors or the residuals to be normally distributed. And so the third plot given in the question is a normal probability plot. And for normally distributed data, a normal probability plot of that data would be a straight line from the bottom left to the top right. So we want to assess how straight this line is. And this line is quite straight. There's just a few very minor bends. This is a really good example of data that is normally distributed. So we can say that the four assumptions necessary for inference have been met.